This is 4.4, correlations and scatterplots, uh, the lesson video. So let's begin. Oh, your objective is that you will interpret scatterplots and identify correlations. There we go. I knew I was missing something. All right, so a couple things we're going to go through. I did kind of put these all on the video for this one, mainly because there's just so much in terms of graphing, and if you don't see it, you have no idea what we're talking about. So notes-wise, for the first thing that we have is a scatter plot. Scatter plots are very important. They're really the real-world type application of a lot of algebra. And so what we got here is in this first one that we have, this scatter plot is talking about smoothies, specifically if the number of grams of sugar and the calories related. So the scatter plot shows the amount x in grams of sugar and the number y of calories in 10 smoothies. Looking at a scatter plot, they do have a bunch of data points, and that's kind of what makes them a scatter plot. And the data just kind of seems scattered. Go figure, right? So looking at A, we want to know how many calories are in the smoothie that contains 56 grams of sugar. So I look at my graph, and I'm going to try and find the area that 56 lies. And I say, hey, look, there's 54 and there's 58. If I go up from there, there's a point at 270. And so for A, I'm going to say there's 270 calories. From part B, it says how many grams of sugar are in the smoothie that contains 320 calories. And so in this case, I'm using my y-axis to find my answer. So I go all the way up to 320, say, hey, there it is. I go across, I find a point, and it's at 70. So this has 70 grams of sugar. Ooh, that's a lot. The last thing that it asks us what tends to happen to the number of calories as the number of grams of sugar increases. So looking at this, I kind of say, hey, as it increases, so does the amount of calories. So as sugar increases, so does calories. Now, does that necessarily mean that the sugars are responsible for the calories? Not necessarily, but there's a pretty good what we call correlation with those. One phrase that you may have heard is correlation does not mean causation. What that means is they can seem to have a trend, but they don't necessarily have to be related. If I said in America we started making more bread, and we also started hitting more home runs in baseball. Are those two related? No, but could we graph both of those as like a function of time and stuff like that? Yeah, totally. Would it look like they're possibly related? Yeah, they would, but it doesn't mean they are. And what that plays into is this idea of correlation. We can have three different types of correlation. We can have a positive correlation, and what that is as our x value increases, so does our y. We can have a negative correlation, which is as our x increases, our y decreases. And we can also have no correlation, where there's kind of no pattern really. You might notice that this positive and negative are very similar to how a line looks on a graph. You can have a positive line or a negative line. Go figure, right? So looking at example 1, we have age and vehicles owned. So looking at the age and vehicles owned, we look, is there a pattern? Not really. Like, it's kind of all over the place. There's no yeah, these first couple they go up a little bit, but they go down later on too. And so we would say there's no correlation. Then I look at B and I say, okay, temperature and coat sales at a store. And I look at this scatter plot and I say, as the temperature increases, the coats sold per day seems to decrease as well. And so for this, we'd say there's negative correlation. And that one, I think, is a pretty good one of ideas of, for especially like a real-world application. If you're a store owner and you're able to plot this maybe over a couple of years, you can start saying, hey, whenever we start getting into May, maybe I should stop having coats available, and we should switch to, let's say, swimsuits. Just an idea. Alright, so make a scatter plot of the data. Tell whether the data shows a positive, negative, or no correlation. So what we're going to do is we're going to graph this. And whenever I first start graphing, I kind of look at my values. And I notice on here that all of these values are positive. And so my graph is going to be in the positive area. So I'm going to keep everything positive. And I kind of like to make my graphs big. I like to kind of be bigger, like too big rather than too small. Now, looking at my temperature, I notice that there's kind of this, it's a big gap from 0, which is where we start on any of our axes. There's a big gap from 0 to where we start. And so there's a couple ways that you might see this. The most common is the little like heartbeat symbol. You may see it as a line with like 2 dashes and continued. That you might also see as well. But I think the most common one that you'll see is that little heartbeat symbol. So I like to find my lowest number, 68, and I'm going to go from there. So I got 68, then this is, so if that's 68, then that's 70, that's 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92. Perfect. Going up, I look at my numbers. I need to go from 1.7 to 5.5. So I'm going to go up by 0.5s. So here's 1, 2, 3, 4, 5, 6. So in graphing this, I'm now going to start doing individual points. So I go, okay, 82 goes up to 4.5, which is right there. Then I go, all right, 78, which is right here, is 4.0. Okay. 68, 1.7, somewhere around there. 87 is at 5.5, so right here. Let's see, 75 is at 2.9, so just about to 3. 92 is at 4.7, which is right there-ish. And then 84, I'm at 5.3. So about there. Now, looking at this, would we have a positive, negative, or no correlation? I'd probably say that this is a positive correlation. And kind of makes logical sense. Oh, wait, I missed one. 71 should have been at 2.9 right there. There we go. I knew I was missing one. This should be a positive correlation. Because as our kind of as the temperature increases, so does the attendance at this whatever it is. I'm guessing it's probably like an outdoor concert or something. All right. Now let's do another one. Let's do one also kind of real world. Again, I like to make my graphs kind of as big as I can. My Y value is value in thousands of dollars, and my biggest is 24, my lowest is 7, so I'm going to go by 2s. So here's 2, 4, that's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Maybe I should change my color. Okay. Oops, not yet. And then these ones are just going up by 1s. 3, 5, 7, and that's 8. That's my last one. All right, I'm going to change color real quick. So 1 is at 24. 2 is at 21. 3 is at 19. 4 is at 18. And right now you're probably going, oh, I see the pattern. But graph them all out because you never know what's going to happen. 5 is at 15. 6 is at 12. 7 is at 8. and 8 is at 7. Now from here I can say, oh, yep, definitely a negative correlation. And then finally, we are going to do line of fit. Line of fit is a part of a kind of a bigger idea, or is a bigger part of a more fine idea. Line of fit we can hand draw. That one's it's fairly straightforward to hand draw. There's also another term called line of best fit. Line of best fit, at least for the class that I'm using this for, we're going to be using digital, a Desmo specifically, to answer this question for us. The main reason why is just finding that line of best fit takes a little bit more math than we really need to do in this class. So what we're going to do is we're going to set this up. We're going to make our scatter plot. So we start by making our scatter plot, which looks much the same. So 1, that's 1, that's 2, that's 3, 4, 5, 6, 7, 8. This one we only have to go up to 19, but I don't think, basing off of that up there, that I have 19 spaces to use. So I'm going to go up by 2s again. So that's 2, 6, 8, not 2, 6, that's 2, 6, 10, 12, 16, 20, 24. And I only need to go up to 19, but I drew those other ones there just for a little bit of reference. We'll need them. We might see them here in a little bit. All right, so number 1, we're at 19, which I'm going to say is about there. Number 2 is at 15. Again, I'm going to say that's about there. 3, we're at 13. 4, we're at 11. Oh, I messed up my graph again. I don't have anyone here to call me out on it. Let's see, this should be different. That should go 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, try that again. 119, 215, 313, 411, 510, 6 8, 7 7, 8 5. So looking at this, I kind of say, okay, I got this line. I can tell you right now that's a negative correlation. All right, that's fair enough. Negative correlation. However, what we're finding is we're finding the line of best fit. And what helps with knowing this negative correlation tells us that our slope should also be negative. And so using that, I kind of say, okay, I know it's going to be a negative slope. Now, the thing that we're going to do is we're going to make a line that, on a line of best fit, or a line of fit, we're kind of, our end goal is to try and have it as equal as possible. The way that I do this, and it's really easy to do with a piece of paper, is to kind of just like guess and kind of like use that another piece of paper to kind of figure out where you have the most lines above and below. Where I'm going to use is and that was a really bad spot. Let's see. I'm going to use this upper point here, this 19 that we drew. I just can't draw that. So it's going to go through the 19, and it's going to go all the way through 5, 10. Let's see if I can. Nope. Undo. Okay. Can I grab it? Nope. All right. Then, and it's going to go in both directions, really. It's going to go up that way. And from those 2 points that I went through, I can make a line. And it helps that you use points that you know. So I know that the points are 1, 19, and that's 5, 10. And from there, I can find my slope. So my slope is, let's see, 10 minus 19, 5 minus 1. So 10 minus 19 is negative 9. 5 minus 1 is 4. And from there, I'm going to use y minus y1, which is, I'm going to use 19, equals m, which is negative 9 over 4, x minus 5. So going from that, I go, okay, y minus 19 equals negative 9 over 4 x. Negative 9 times 5 is positive. Oh, whoops, I used the wrong number. That shouldn't be a 5. That should be a 1. Thought that was weird. Negative 1. So that makes positive 9 over 4. I'm going to tell you right now, 9 over 4 is the same as 2 1/4. I know I normally don't do this, but it actually makes this a lot easier. So we're going to add 19 to both sides, and we get y equals negative 9 over 4x plus, so 19 plus 21, or 19 plus 2 is 21 1/4. And so our y-intercept is 21 1/4, and so our m is negative 9 over 4, and our y-intercept, or the place that we kind of start normally, is 21 1/4. And if I drew a better graph, if I was able to draw a better graph of this, you'd actually be able to see it to go through there. So that concludes the lesson. So check with your teacher on your assignment, and have a good one.